Let's trace this demo program called TurtleWithStaticMethod. Java will begin executing the code in the main method. Notice these other two methods are typed out and placed below the main method. We're going to be calling those methods at the appropriate time. They're both considered static methods, and they're in the class called TurtleWithStaticMethod. And this is a client program that simply has a main method which executes. Okay, let's begin. The first line of code declares an object variable named Earth, and instead of being an int or a double or some other data type like string, it's a world. And the world data type really references the world class. And notice that Donatello and Michelangelo, they are object variables, and they also have a unique class, a data type called turtle. For this program to work, the world and turtle classes, which are not built into Java, by the way, must be able to be accessed by this file. And because I would have set this up properly in my Eclipse project, you can assume that this code will work. Earth. Earth is an object variable, and it's being, instead of being set equal to 0, it's being instantiated to a world object. So it's an object variable that, because of the word new here, it's being created as an object, and it can then therefore be used in this client program. The 500 and the 500, those two parameters, they are being passed to the world class, where you can assume there's something called a constructor, and the two 500s, if you look it up in the Turtle API, well, the world API, you'll see that the 500, I think it means the width of the world, and 500 is the height of the world. Okay, Donatello. Donatello is an object variable, and it is instantiated as well in this client program. And the 100, 200, and Earth references, those values, you can look it up in the Turtle API to see what they do. I believe the 100, 200 is the XY location of the turtle within Earth, which is a previously declared world object. Now what this looks like is just a matter of your imagination. Since I'm not executing this code, and there might not even be a graphical interface for this, you're going to need to have a strong imagination to remember essentially where Donatello is at the position 100, 200 versus where Michelangelo is 200, 400. The next line of code, draw square Donatello. Donatello is acting as a parameter. We call this an actual parameter, actually, and it's being passed to the draw square method, which is right here below in this client class. And there is the draw square method. The data type does match up correctly. Donatello is indeed a turtle data type, so he can be plugged in for any turtle, which is also a turtle data type. Obviously, if this were the word int or double or string, there would be a type mismatch, and we would probably have a squiggly underlined compile error with this program. Next, we now execute the code that's in the body of the draw square method. Well, we see that we're referencing any turtle, the parameter name, but really, right now, because we passed Donatello, it's Donatello that's doing the square drawing. So pen down, the pen down method, you can look it up in the Turtle class API, but pen down must set the pen down on the graphic screen so that you're about to draw something. Forward probably moves the turtle, the given turtle, in the forward direction, whatever direction he or she is pointed at the time. I'm not really sure of this because I don't know in what direction a turtle points when it is instantiated with this line of code. I assume that it's pointing north, but without looking it up in the API reference documentation, I'm not totally positive. So let's just assume that he's pointing up the screen. So forward. When forward is executed, I think it moves 100 pixels. But again, you'd have to look that up in the API. Oops, it's not a straight line, just bear with me. Turn right, re-points the turtle to 90 degrees to the right of whatever direction he or she was originally oriented. And then another forward moves you another 100 pixels. Another turn right would then point you down, and another 100, another forward would move you forward, and then another turn right. If you think about it, if the turtle is pointing down, the act of turning right would point her that direction. And this last forward would complete the square and put the turtle, the pen or the turtle, back to the original location. So hence we do have a square. Once we are finished executing this code, we hit that curly brace, which means go back up to the referring method that called this method, and we're back up here then, and we just executed that line of code. Next, we do the same thing with Michelangelo, and because Michelangelo begins at 200, 400, somewhere else on the graphic window, we would have another square. Actually, it would probably be down here somewhere, because the 400 for y is probably below 200 on the y-axis. Okay, the last line of code. Michelangelo.forward make random. We have to follow the order of operations and work from inside the parentheses out. So make random num with empty parentheses, that is a call statement. That's a function call, a method call. We're calling the method make random number, which is not built into Java. It's typed out right here. And there are no parameters, so let's just look at the line of code that's in the body of that method. Math.random, according to the math class that's built into Java, the random method returns a number between 0 or including 0 and 1, but not including 1, so up to like 0.999999. If you multiply that times 100, you end up with a number between 0 and 100, but not inclusive of the number 100. And if you add, according to order of operations, I believe the computer would then typecast. No, I believe it adds 1 next. So you really have a number between 1 and 101, but not inclusive at 101, exclusive. And now you typecast that to an int. So if there was a number like 50.6, some real number, some decimal number between that those two endpoints, the 0.6 would be chopped off. Sorry about that. The 0.6 would be chopped off, and the number 50 would be stored in the local variable num, and that 50 would be returned back up to the method call. And therefore, we can pretend that we have some whole number between 1 and 100, perhaps 50, perhaps 56, possibly 62 or 13. Some random integer is now in the parentheses of the forward call statement. So we are calling Michelangelo with this method called forward parentheses 50. Because there are two versions of forward in the turtle class, forward can be called with empty parentheses, but it can also be called with a whole number in the parentheses, in which case Michelangelo, wherever she ended up, is moving forward 50. I believe she had already drawn a square, and she was currently pointing west, and therefore I think we would have a short little line of 50 or some random number of pixels jutting off to the left of the original square that was drawn up here.